As part of the syllabus already, we've seen the equation of the line in two different forms, y equals mx plus c, which we call slope-intercept form, and then standard form. But there's a third equation of a line that's really helpful in creating equations of lines, and that's called the point-slope form. So, point-slope form of a line has a point, which we're going to call x1, y1, and the slope, which is m. Let me make this all a little bit smaller. Okay, so in point-slope form, I end up with y minus the y-coordinate of the point we know equals m times x minus the x-coordinate of the point we know. Notice if I divided this whole thing to the other side, I would get y minus y over x minus x, which is my formula for slope. So that's why we call this point-slope form, because it comes from slope form, and now we're just using one point, not 2 points, because we already know the slope, and we know the final equation of a line. We want it to have x's and y's in it, no matter which form we look at. So let's see how we can use this. And we'll start with example 12a. So we want parallel to y equals 3x plus 2. Well, in y equals 3x plus 2, we know that the slope is 3 because it's the coefficient of the x value when I'm in slope-intercept form. So then my parallel slope, the slope of a parallel line, is going to be equal to the slope that we have. And we want to go through the point 1, 2. So now our point x1, y1 is going to be the point 1, 2. So you can use any of our forms of equations to try to find the final equation. And so I'm going to show you using this method and using y equals mx plus c. So if I use my point slope method, so point slope method, I'm going to do y minus 2, because that's this coordinate, equals m times x minus 1, because that was my x-coordinate. Now I'm going to simplify this. This is just y minus 2 on the right, 3x minus 3 when I distribute. And now I can easily turn this into either standard form or slope-intercept form. So I'm going to move the 2 to the other side, and I get the equation y equals 3x minus 1 from when I add 2 to both sides. So now I have my parallel line. It's parallel to this because I have the same slope, and I've got a different y-intercept. Let's see what happens if I use the slope-intercept method. So then I would be using the equation y equals mx plus c. So I know my y is 2. I know my slope is 3. My x value is 1 plus c. So now in this method I have to figure out what the y-intercept is. 3 times 1 is 3. I'm going to subtract 3 to the other side. 2 minus 3 is negative 1. So that tells me my c value is negative 1. This is not the equation of the line though. I have to go back and plug in the slope and the y-intercept. So I'm going to get y equals, my slope was 3, my y-intercept is minus 1. So I end up with the same equation. Remember, at the end we're asked for the equation of a line, so we can't just find c, we have to put it back into the equation of the line. And this is the equation of our line in slope-intercept form.